Good morning. Thank you for joining us today. My name is Patrick Lane, and I work for the Montana Department of Transportation. And I'm joined by my colleague Lenci Kappes, who also works for the DOT here in Montana. We're happy to present to you folks today. We wanted to talk about the evolution of bridge design here in Montana and the steps that we've taken to really create something that has allowed us to change the way we do things when it comes to bridge delivery. We've had the opportunity over the past few years to work with our partners at Autodesk, and we're really excited to share with you not just some of the work that we're delivering, but some of the methods that we are actually using to deliver it, as well as show you how our workflow has evolved from conception several years ago to the point that we're at today. Once again, we appreciate your time today. And without further ado, I'd like to introduce you to Lenci Kappes.
Thanks, Pat. I'm Lenci. I work in the MDT Bridge Bureau. I'm the Innovations and Complex Structures Engineer. But as Pat alluded to, I wear many hats, and one of those is to help with our digital delivery program. And I'm really excited about talking about the evolution of bridge design because a lot of this helped our transition into new ways of doing things towards that. And so with that said, I started with this screen because this actually shows, it's a model of our progression through it. It's very static, not dynamic at all. And with that said, let's start carving through some of these waves. And I think the best place to do that is to figure out where we started. And so if we roll back to about 2018 and before that, our bridge program was made up of 2D lines. And so every time we designed and created a bridge, we would draw one line at a time until it slowly looked like a bridge on the page. And more or less, you start to carve through 20 sheets or however many sheets you need to be able to build that bridge. And that's what we did. And I want to go through the pros and cons with that. The number one pro was familiarity. It's the way we've always done it, whether it was with a pencil, a ruler, and an eraser on paper, or when we finally graduated to CAD, it was still a 2D process, one line at a time. And we knew that there was a lot of cons to that as the age of technology was changing things. The number one thing is our bridge plans were completed after everything else was done. Number two, they're very static, and the changes are difficult and time sensitive. And so we're putting our bridge plans out there at the end, and they're hard to change. It offered very little opportunity for collaboration until they were done. And aside from all those inefficiencies, we also could tell that bridge was following behind our road design counterparts. Whether it's in open roads or civil 3D, we could tell that they were working towards and having a lot of success with a model-based design of their corridors and other things. So with that, we started on this process around 2019. We started on a process to start to think about transitioning from that 2D world to a 3D world. And so we drew upon past experiences of printer design, turbine designs for airplanes, and we knew that other industries have been using 3D design for a long time. And so we theorized that potentially we could even start to create some of our bridge components in a 3D way. And progressing into that, we talked with our management and we were afforded the opportunity to go out and try and do a proof of concept. And one thing that I can't stress enough is figure out some goals and visions, figure out what you really want to do. We want to be more efficient. We want to improve quality, update our processes, and we wanted to communicate better. And I won't read all those, but I think the number one thing is to form those goals and visions and find some folks to help you do that. And that's what we did. We figured out who in Bridge wanted to work on this, and then we got a road designer because it was important. Whatever we did in road, or in Bridge, whatever we did in Bridge, we know that our bridge plans and our bridge model would go into the road plans, and so we wanted to have that correlation. And so one of the slides we showed our senior management team when we finish our proof of concept is, yes, we can build bridge components, and much like this one, it has circular piles, a number of bearings for beams, and we showed them that we can build this, but we can also change some parameters. So I'm just going to kind of fly through this video and show how we dynamically change that pier to have fewer beam supports. And if I scroll a little bit further, it's actually changed from a 2% crown to on a skew. And so, yes, we could build these bridge components, and furthermore, we could bring these bridge components into a geographical location with another, and I'll talk a little bit more about the tools we're using here in a little bit, but we could bring those components into a geographical location here in InfoWorks and really collaborate with hydraulics, environmental, road design. And further yet, we could then bring those same bridge components into a program called Revit, the same program that architects have been using for a long time. And real time, we showed our senior management that we can actually put rebar in this entire bent cap in about 8 minutes. 7 minutes, it looks like. So this is a pretty powerful evolution of showing these, the change, what we could do with 3D tools. And then, of course, that final plan set that's also important for our contract documents. This is just another emphasis showing that these are going to look very similar to the 2D documents that we were used to for the last 100 years. And so with that, we came up with something that was termed the workflow. And this is maybe what it looked like in early 2019, but by the time we actually had that proof of concept, this had evolved quite a bit even before that first initial concept was given to our senior management. With that said, that kind of wraps up a good summary of what we call Workflow 1.0 and Bridge. And that's actually, I know that this workflow is pretty small, but the yellow boxes are an Autodesk program called Inventor, and that's where we're creating our bridge components. The green boxes in our flowchart are a program called InfoWorks, and those are identified in the slide right here. InfoWorks, and that's where we're out in the real world spinning our bridges around, collaborating. And then as you move down towards the bottom, these cyan boxes are Revit, and that's where we're going to be creating our road plans. And we actually, with Workflow 1.0, we designed, we detailed, and then we actually constructed the Little Dry Creek Bridge, and that was out in our Glendive district in the eastern side of the state. So this was a great workflow, and it allowed us to show our senior management that this is the way we used to work. Road design and hydraulics, they get in there and do a whole bunch of information, provide us some recommendations, provide alignment, provide stationing, and then Bridge will get in and start to do that work. And what we learned is if Bridge can have a model, if we can bring a model to the table, Bridge can then be in that early design process a lot better than we currently were with the old 2D workflow. And we theorized that we might be able to even unite our workflows a lot more by sharing data and working on the same files. So even back in 2019, our proof of concept suggested that, you know, if this is 100% design time, perhaps that if we can at least just all be working and collaborating together, you know, actually have a bridge model and say, hey, this is what we're visualizing. We theorized maybe we could save half of the design time. And then, you know, if we could start to actually, you know, work on the same alignment, pull that alignment, and our bridge is right on that, and et cetera, perhaps we could even shave that down a little more. And so we had a lot of pros to 1.0. We completed, we changed the way Bridge could design and deliver projects. And basically, we did solve all our goals and visions, and we called this a huge success. But we also noticed a few things with that workflow. That workflow requires we would put all our bridge parts in InfoWorks and then publish those to Revit. And in InfoWorks, our models were in grid. And Montana has a kind of a unique grid to ground issue, perhaps. A lot of times that value is really close to 1. But in Montana, we have one state plane for our entire large state. And so there's discrepancies between grid and ground that tend to be larger than what other states and other entities see. And so I think that this is a Montana specific thing, but it was something that was creating a little bit of friction when we hit that publish button between Revit or InfoWorks and Revit. And aside from that, we also were very particular about what we want to show in our bridge models and our bridge plans and our joints and our water stops and all these little things. And we seem to, as a bridge bureau, we seem to be very involved in that. And so we wanted to have, I think, a little more design flexibility. And then our custom parts and models are driving our solutions. And so we wanted to look at a different way of once we design these to go directly into Revit with our parts. And one other thing I wanted to mention is this software that we're using, the Autodesk suite here with Inventor to draw our 3D components and InfoWorks to collaborate and Revit to detail our plans. Is extremely powerful, and in bridge and in infrastructure, it's evolving very quickly. And so some of these problems that we're even talking about in this list are actually solved right now. But the way our state works and the way we install software and those things, we're not always able to keep up with those. And so we, in our workflow search here, and I'm going to click on my evolution button because we're going to take a step forward and just figure out if there's different ways to start to address some of those issues. And so one of the things we looked at, and we called this workflow 2.0, was to start to transfer our Inventor parts directly from Inventor to Revit using SAT files, .asts. And we did this by, let's just ship the whole bridge over essentially in a SAT file. And then there's to break that into parts essentially in Revit, and then we started to put rebar in those parts. And for one important thing in Montana with our grid to ground, our Inventor parts were in ground and our Revit was in ground, and so we had that 1-to-1 between where we're creating our parts and where we're detailing them. The important thing here is we're still using InfoWorks all the time. We can still take those models and put them in InfoWorks for that. Probably one of our most important things is the collaboration that we get from these. And this was a vast improvement for us here in Montana, but it did bring up some efficiency concerns. That streamlined 1.0 workflow is extremely efficient, and it's the way the software is really geared towards, and it is good. And so when we did this, we noticed that we were taking a step back there. And that's one reason I'm not going to spend a lot of time on Workflow 2.0, because we quickly evolved to what we called Workflow 2.4. And this was a small leap forward, but it solved many of the efficiency constraints that we saw in 2.0. And it was a pretty small change because all we started to do was we exported SAT files of just parts of the bridge, and then we would assemble those in Revit. And we kind of noticed, I think, how the architects were working with their walls and different things. And so we said, oh, okay. So that we kind of emulated that. And what this did is it allowed a lot more flexibility and faster updates, especially like when we had rebar and other things in Revit. So that process, it was a lot more flexible for changes. And this actually was driven by a project that we did that I wanted to talk a little bit about. And this project, I think, is really important in the conversation with our evolution of our bridge design process. And so Wolf Creek Denton actually was a bridge that on December 1st, a wildfire started just west of Denton and actually burned our timber bridge. And it's a real important story for here in Montana. This is a small community, and this was one of the two ways to get into Denton. And there's just pivotal to this community. And so we looked at this and we knew that we had to do something. And so we raised our hand and said, let's fix this bridge, and we're going to use our new software so that we can do it quickly. And so this bridge burned down December 1st, and we had a barbecue and a ribbon cutting in July, so just 7 months later. And I wanted to talk a little bit more about that because we had matured enough in our bridge design process at this point that when we were scrambling to figure out who was going to do this work, we were able to raise our hands and say, we can do this. And that's exactly what we did. We actually sent an email out that said, we have software and a team that can eat this bridge for breakfast. And I wanted to tell you a little bit about that meal because it all starts with a bridge model. And when we have that, we can collaborate like what we've been talking about. This is actually showing that bridge in some of the hydraulic workflow. So they're able to, instead of us maybe telling them, well, we think the bridge is 115 feet, we think that the skew is this, we think that, we actually can just say, hey, here's the model, and then they can bring it into their software. So with that said, there's some cool things that we're going to be talking about. We actually started out with a 30-degree skew. Just when we first looked at the site, the hydraulics engineers looked at the site, we all thought 30 degrees. Well, it turns out once all the fancy flow things are all figured out and everything in hydraulics, we actually wound up at a 20-degree skew. And we were optimizing the road grade. A lot of these old timber bridges were fairly level. And so we actually had to introduce a little bit of grade to hopefully get that water to drain off the bridge. And so we're continually optimizing these structures throughout design. And that's one of the huge things with Workflow 2.4 that I'm going to show, that this workflow really enabled that. We could do that with the old one, but the efficiencies in 2.4, handling that part by part was huge. And so I mentioned that we changed the grade. And so here's a quick video, a recording of that bridge model. This is in the Inventor software. And the grade was at 0.1%. And so if we watch the right end of the bridge here, I'm actually going to change the grade to 1.0%. And you'll see that drop down. The whole bridge is parametric for this project. We wanted it to be flexible, and we wanted to be able to make changes as they came up in design. I'm going to change the length. I'm actually shortening or lengthening the bridge right now, and then I'll bring it back to where it was. And so that change, we're optimizing the beam length for this particular bridge. As I mentioned, we actually had a 30-degree skew, and we ended up changing that to 20. So you can see that dynamic change real time as we adjusted our model. And then we had supply issues. If you've been in the industry lately, at least in Montana, we've had a lot of supply issues. So we actually couldn't get 16-inch piles for this in a short time, but we actually got 20-inch piles. And so we're able to change that. In real time, we were changing this with the contractor on board. And as you saw, I just adjusted the cap width as well based on his request. And so it's just kind of showing you how powerful this model is. And if you think about, 2022 compared to back where we were in 2018 with those 2D static lines, this is a monumental step forward for our bridge department to be able to react and design collaboratively like this. With that said, we also, it's important to get those contract documents out. So in this view, we're going to be looking at that same bridge model and our standard general layouts. I'm sure we're all used to general plans, general elevations, that type of thing. But the big difference here is that it's based on that same model as you'll see here. So this view is showing Revit, and this is the bridge model. This is a view of the steel reinforcement in the structural slab that I placed over those box beams. And then, of course, we built the grade into these caps, and so this is showing kind of a 3D view of some elevations, and then this is some of that rebar, so that we could not only work with the contractor, but also, of course, get the rebar in the beams and into the rebar schedules. And, of course, the cap and wing wall reinforcement as well, diaphragms, that sort of thing. So here's a site view. It's just, I like to show this to show we can bring in all that information. There's the road alignment, wetlands, different things like that. And moving on, I think I wanted to really focus in on that rebar cage. We're actually working real time with the contractor, and so he's kind of in a way looking over my shoulder as we design this, and he came up with a solution to improve our reinforcement so he didn't have to slide all the longitudinal bars into the voided slabs, or sorry, the slabs. And so we changed that configuration. It was structurally equivalent, but with that suggestion, it improved how quickly he could build these beams. And I think just focusing on this level of detail with that model detail and then the contractor's actual construction shown on the right, we're matching that level of detail nearly 1-to-1. And I think it was powerful on this Denton Bridge because we saw our model become reality very quickly in the same season. Another thing we did with this that we could have never done before is, now that we have a bridge model, we're starting to figure out, well, what else can we do with our bridge model? Of course, we're going to make those 2D contract documents, but what else have we been doing? So I was able to connect up with Brandon Jones, and he's a specialist transitioning some of our material from design to construction, and they've been doing this for the roadway items for, I think, since about 2018. They're doing a great job of getting that design intent for the roadway, all those surfaces and everything else, into Trimble Business Center, and then where necessary they can build models for AMG and different things, but we've never really been able to ever even think about it actually for the bridge concepts. But on this bridge, we're able to connect up with Brandon, and in only an hour and a half, we were able to take our bridge and all these important surfaces I have, the pile locations, and as you see here, we actually ended up bringing the whole bridge in. But we're able to essentially take my Revit model that all my 2D contract documents are made from. We took that Revit model, we brought it into Civil 3D, and we scaled it from round to grid. And then in real time, Brandon brought it into Trimble Business Center. And then we were able to double check my calculations for stations and offsets, and we were matching 1-to-1. And so that was a huge step forward. And so our construction inspection team in this case had the ability to go out and check all those important criteria for this bridge design and make sure that it was going in place just as we had intended. And I went ahead and brought a few pictures in here just to kind of elaborate on that. You can imagine checking the elevations on this formwork with that that construction model, I guess I'll call it, from Trimble Business Center. But also, as with any skewed bridge, there's some complexities that have to be accounted for somewhere for everything to fit together. And you'll notice, it might be hard to kind of tell in this picture, but on the far end, that's a head-on line. And then, of course, this would be, this near side would be back online. And so the distance to the top of these caps is actually smaller here because the grade's coming down and taller in the back. And not to go into bridge design itself, but all I'm trying to maybe say is there's a really complex 3D surface. And so it's really nice for us, of course, not to only just have that in the 2D document, but to also have that in the construction inspection hands team and on their survey equipment. And it's a huge success for this project. I wanted to stop here just a little bit as I have a time lapse of this bridge coming together. But when we actually stop and think about it, this bridge burned down overnight on December 1st. Survey took about a month and a half. Amazingly, after the fire, storms blew in, sub-zero temperatures. And so around January 15th, survey comes in. But I think it's incredibly powerful to understand that our new process doesn't take longer. It actually was way faster to build a parametric 3D model. We actually had, we were approaching a price with the contractor in February on 60% plans. And one of the things I think that shows is how powerful a model is, because MDT, the contractor, and the design build engineer are all looking at the same model and that same understanding. And then when we know it's linked to those concrete documents, those concrete, the contract documents, we had a high level of confidence and in those. And so to see a team with those three entities be able to bid a project, we bid the bridge portion of the project early because we were struggling with supply chain issues. So we were getting early work packages together to be able to have those items on site in time. And so when you think about survey January, mid-January, and then actually bidding a project in February, it was extremely powerful for Montana, and it was just one more proving ground for this new workflow. But we didn't stop there, and we were really happy with workflow 2.4, but we noticed a change, and so and this was such a significant change that we actually called it pi, and we started at 3.14, and then every time we figured out a new little thing that or advantage to this workflow, we were adding on digits. And so it's just kind of a joke among our bridge bureau on the pi thing. But we started to look, we noticed in 22 that there was an Inventor Revit link, and so you can actually export a Revit model from Inventor. And so that kind of was an upgrade, I should say, from us exporting the .SATs. And I thought instead of more PowerPoint, I thought about just let's explore and see some of the advantages of that. So I'll drop out of PowerPoint and jump into Autodesk Inventor. And I'm using this truss bridge that we're working on. It's a little single lane truss and the sidewalk. And I wanted to go through a few of the components. First, possibly the level of detail. So you'll see a new curved railing that we're looking at. We have a spread footing on one end. The side of the river is solid rock, and so a spread footing is what we have. And then on the other side of the river, interestingly enough, is very poor soil, and so we're building out a deep foundation on that end. I also wanted to point out that there's the existing abutment in here, and we're actually going to leave that and build behind it for environmental purposes. We have a nice wall that we want to work with based on some of the things you'll see in a little bit. And we're looking at monuments and all sorts of fun things. Is what I'm kind of getting at is the level of detail that we have even on a preliminary bridge like this. We're still actually scoping this project. But what we found is we can put this information together fairly quickly. Another conversation we're having is if we should have pickets on this for safety considerations. And so we'll be working with the district and county on that. Do we want them on both sides? So you can see some features in here that are extremely useful for conversations early on. And I think what I really wanted to point out with Inventor is this is where we can create, we can visualize, we can imagine what we're going to do very early, and then we can provide this to folks. And possibly I wanted to just grab any random custom part here and maybe show a little bit more about this. One component. So this is a monument that we're just thinking about on the corner here. And so I'll open that as an example to work with. And so you'll see it's a fairly simple thing. And I maybe even want to jump all the way back to 2D versus 3D. And one of the things that we've been training with, a concept, is we're actually not that different from 2D. We're just expanding 2D into the 3D world. And so you'll notice all this actually does just start out with a sketch. And a lot of our folks all of a sudden can see this and then all of a sudden say, okay, I can do that. And then it's not much of a difference to be able just to click extrude, and then you can extrude that sketch up a certain amount until you get that feature that you're looking for. And so I'm going to just roll this part down a little bit more. You can see that we, in the same fashion, we edited or added a cap to that. There's a little loft for an architectural top on that. And of course, I'll jump down to the bottom. But you can see this is just made up of some simple tools to make this exact component that we visualize that we want. You'll even see a little cutout to avoid another feature on the bridge. And so jumping back to the 3D model, you can all of a sudden understand how these come together fairly quickly, even intricate back walls and items like that. And then the big focus of workflow 3.14 is the export to Revit that we're using. And so you'll see a whole bunch of Revit exports right here. And we've broken up this up into strategic ways that help us move this information to Revit. And so we'll see a lot of these Revit exports, but let me go ahead and click one. And we'll see the Edit Simplify menu come up. And this is the same model then, and we've chosen to pass all these concrete parts over to Revit. And so that's actually going to make a Revit file that we can simply open and begin our bridge design and detailing in Revit. So with that said, then we break up the other parts into, sorry about that, didn't mean to push OK there, but we'll let it finish. We'll break up and export the other things like the MSE wall, the bearings, joints, etc., rails. And what we've found this does is it's extremely agile to be able to update even something as large as this truss. You can imagine, you know, if I calculate the thickness of these gusset plates, we may not want to update the whole entire structure if we can just then update these gusset plates. And picking on those gusset plates one more time, let me do a quick edit simplify and show that they're in their own package to be exported. And with that said, say that we had changed the thickness on some of these, one of them perhaps, or all of them. We would simply come in here, maybe check what we're sending over. Oh, and I just noticed we added the pickets to this. I had noticed that before, but I'm actually going to exclude them from from this if I was to update it again, so you can kind of see how I pick those. Maybe just another quick menu over here to show what I call opposite land, but this button actually shows you what's not being exported, and then of course what is being exported. And so then we'll quickly just, if I was going to update those, I would just hit OK, and then all our changes would pass into that Revit model that is created when we do that. And with that, I think I want to jump over to the Revit side and show you the same structure here. And so I'll just go to an illustrative overview of the project, or just that's what we named it, because it's actually going onto our sheets. I can show that in a second, but this is just a 3D view of this project. So you can see that this is that model from Inventor, and now we have it in this space that we can quickly use all those fancy tools that the architects have been using for decades now, and we can apply those to our bridge components and create that plan set. But to touch back, and I want that direct link to be clear with Inventor on this workflow 3.14, you'll see all those same links. And so if I had clicked OK, I didn't want to take the time to, but I could have simply then updated the gussets here, and then that's real time. A lot of times we're making those small changes, as I showed you on the Denton Bridge, and so that update tool is very powerful. Your dimensions will stick to those parts. Rebar will actually grow and shrink as you change the size of a cap. So it's extremely powerful to be able to do that. And jumping back down to our plan set, we can, of course, click through. I guess before I do that, we can click through all these different views. These are all just different views of that same model. So in every one of these, we'll just see different views of that model. Perhaps we want to go look at this section view. And so I just double clicked on that. And there's, of course, a section of this truss. And you can pull elevations of this. I think one of the powerful things we've noticed is, this is in 3D space, and you can bring in even LiDAR to this model and be able to see that real time in these. I'll go down to, of course, as you create sections and plan views and elevations, of course, we're doing that with intent to bring these into sheets. Sorry, I clicked on the wrong one. And so, of course, then we're pulling those plans and elevations into our sheets. And I'll go ahead and just show how easy that process is. Oh, of course, can't bring it into the same one. Instead of doing that, let me bounce around to a few others. Here's a footing plan, for example, and some bent examples, reinforcing. And so another thing I want to emphasize about this process is, as I mentioned before, we're actually just scoping this bridge. We're trying to figure out the extents of it. We're not in full design yet, but you're actually going to see that the designer in this case has actually built out a fairly involved set of plans. He's definitely figured out some of the sheets, and it's fairly nice for me as a structural engineer to be able to get in here, and maybe I need to pull some dimensions. Maybe I just want to know how far along this is. Maybe I need some of these views to work with the community, that type of thing. How wide is that sidewalk? If we do have an interference, what is that? And so it's pretty cool to be able to see, even very preliminary, that we have a bunch of these views created, and that we're readily building this out. The other thing that I've mentioned before, but is worth mentioning again, is the ability to be able to change this. And so with that said, we're really excited about where 3.14 is. I think throughout our our discussion today, we've seen that we've come a long ways in our evolution of bridge design. One of the most important things that we've done is be able to have that bridge model to collaborate. And so I wanted to show, before we end here, I wanted to show InfoWorks. And this is another program. You'll see that same bridge model brought into this space. You'll actually see a LiDAR of the old existing bridge. And so you can imagine when I was at a community meeting with this town that it was a very nice discussion to be able to say, we are widening this bridge, but most of the widening is going to go into the sidewalk. Things like that are very important to this community. And again, with utilities, we'll see that we have definitely some utility conflicts that we need to resolve. So you can imagine the discussions that we can have with this information. And we've already built out many of our design documents. So with that, I appreciate what we've done. I wanted to jump back into PowerPoint just to wrap things up. Oh, and I pushed there we go. So wrapping up our workflow 3.14, I think you can imagine the evolution that we've felt here at MDT in our Bridge Bureau from 2D to this 3.14 workflow. But we want to go much further than this, as we showed with that transition of our design intent into construction before. We want to start to look into as-built. How much of this extended attributes, how much of our design intent can we keep into as-built? What do we need into as-built? What will we want to see 10 years from now, 15 years from now, 20 years from now? We're looking into things like ArcGIS. I think the most important thing that we want to emphasize is the evolution has just opened so many doors for us. And every time we think that we're like, oh, this is it, this is awesome, we realize that another door's opened and we have this huge opportunity for more efficiency, more quality, and doing things that we've just never even dreamt that we could do before. And so I always show that, you know, everybody has to start out somewhere. And I always think at some point we're going to be off and running. But if I had to measure us and knowing how far we've come, but also starting to realize where we can go, I would put us somewhere in this crawl to first step area. But with that, I wanted to turn it back to Pat Lane just to, with any closing thoughts.
Thanks, Lenci. Lot of stuff to absorb there. I know, speaking from our perspective here at MDT, we're extremely proud of where our bridges and structures group is going. Actually, the agency has just finished a 14-month project implementing the Autodesk AEC collection for all of our other design functional areas. And as Lenci mentioned, with all of the work that's been done in bridge, we're now positioned to move our other functional areas to team with them. Collaboration has been an ongoing win for the department. Using these new tools, we've seen similar successes within our right-of-way, our road design, our environmental groups, and we're really looking forward to what the future holds for the way that we deliver projects. I know that Lenci also in the beginning had talked about digital delivery. I also wanted to give a plug for digital delivery and for all of the DOTs that are moving in that direction. Of course, here in Montana, we are, as Lenci said, based on the bridge workflow, consistently reevaluating and changing and looking at how we can deliver projects holistically, much more efficiently, and looking at how we can provide better data that has greater value. So as we end here, Lenci and I want to give a thank you to the American Council of Engineering Companies of Wisconsin. It's been a pleasure to share this information with you today. We encourage you to reach out to us if you have any questions. We also want to throw out there that over the last 14 months, we've had a great partnership with the Department of Transportation there in Wisconsin. We've performed a lot of peer shares on some of the great workflows that they've designed, how they're delivering projects, and the DOT in Wisconsin is doing exciting things as well. And we're happy to be in touch with those folks and working in similar directions. With that being said, we're going to sign off. We very much appreciate your attendance today and hope you have a great rest of your week. Thank you.
Thank you, everyone.